Good morning, everybody. This is now Wednesday morning, and I have your notes for you today. You should have completed your worksheet yesterday. That was homework, and that key was posted on Classroom. Today, we are going to go through day 6 of notes, and you can see here that today we are going to try and create continuous functions, and we are going to go back to something we visited before, which is finding the equation of the tangent line at a specific point. Now, when we start talking about creating continuous functions, here's your first problem. And this is actually one of the problems that you're supposed to do for homework tonight, but I decided to go ahead and include it on the notes. So when you get to this problem in your homework, you can go ahead and skip it. So it says, define f of a so as to make f continuous at a. Well, first of all, if you look at this function, you will see it is not continuous at a. I am saying that a is 0. You cannot plug in 0, which means it is not continuous here. This actually, if you were to graph this, would be a hole at a. So the question is, can I fill in this hole? If I can fill in the hole, then I can make it continuous. Well, in order to fill in a hole, I've got to figure out where the hole is. Well, I know the x-coordinate is 0 because I am specifically telling you this. So I know the x-coordinate is 0. I got to figure out what the y-coordinate would be so I could fill in that hole. So in order to do that, we need to find the limit. Okay, so as x approaches a, of f of x minus f of a. Well, I can't plug it in the way it looks, so I have to go ahead and try and find the limit of this thing as x approaches 0. So what do? Well, if you take a look at this thing, I'm not sure if Mrs. Hurt has given you this identity or not, so I'm going to go ahead and give it to you here. The limit as x approaches 0 of e to the x minus 1 over x. This thing has a limit of 1. So this is like one of those special trig limits that you guys proved a while back. So if you look at that and you look at my green writing here, you can see that we're super close to having that identity. So I need to do a little bit of substitution. I'm going to say that, which means I also got to solve for x, which would look like that. Okay, so what am I going to do here? I'm going to do my substitution. I have the limit as x approaches 0 of that, which still gives me 0. So now let's do my substitution. Which looks like that. Well, now you can see I have this identity, and we know that that thing is 1 from this. So basically it's 1, and I still have this negative sign down here. So basically that's -1. So what does that mean? It means that if I put a point at 0, -1, I could fill it in. Okay, so technically, if I want to rewrite this, I am going to make this into a piecewise function. There are my two pieces. I'm going to use the top piece if x is anything but 0. But I'm going to use the bottom piece if x is 0. So basically, it's kind of like a hiccup where I'm going to fill in my hole with this bottom piece right here. Because I found out by doing the limit that the y value would in fact be -1. Okay, so we have redefining your functions for you, and you'll have 2 of those in your homework tonight. Okay, so let's go to finding the equation of the tangent line. Well, you guys know how to do this. We've done this a lot before. If I'm going to find the equation of the tangent line, I need a slope. And we find slope by finding a limit. So I have the limit as x approaches 0 from this right here of f of x minus f of a, which I already know what that is from right here, all over x minus a. Will just be that. Well, that is identical to your identity. You know that this thing is in fact 0. So now I'm going to use this as my slope, and I'm going to plug it into point slope form. Y minus y1 equals m times x minus x1. And when you simplify all that down and isolate the x, you get that as your tangent line. All right, let's try another one. This one's going to be a little bit more complicated for us. We went from really easy to a little bit more complicated all in one fail bound here. So here we go. If I want to find the equation of the tangent line, I'm going to need to set up a limit. So I have the limit as x approaches a of f of x minus f of a, which is right here, all over x minus a. Well, looking at this, it looks like I need to multiply by the conjugate, which will give me that. So up top, I get negative x squared. Actually, I don't think I'm going to write it in that order. I'm going to say 1 minus x squared. And then I have my denominator, which looks like this. The numerator will factor into that. And then these will cancel as opposites, which means I need to put a negative out front. And now my denominator looks like this. So if I plug in a 1, my numerator gives me negative 2. My denominator will give me a radical 3 plus radical 3, which gives me 2 radical 3's. And then if I rationalize it all the way down and I simplify everything, it'll end up with a slope of that. So now I got to use that slope in my point slope form to find the equation of the tangent line. Actually, for this one, it looks like I use slope intercept form. So I'll go ahead and do slope intercept form. Y from my original point up there equals m times x from the original point, and I'm trying to find the b. So now all I got to do is solve for b here. So I'm going to have to find the common denominator. You will also have one like this in your homework as well. So that looks like your b, which means your final equation looks like that. Okay, so that is all of the homework or notes I have for you for today. Your homework is a combination of both of these types of problems. And I wonder if I had some more examples that I wanted to show you. I think these are for a different day here, kids. So I'm going to go ahead and put your homework up here. And let's see if what I wanted you to do here. I think these must come out of your book, and actually I do think I'm going to do these for you. These are out of your textbook, and we're just going to do a couple more examples so you can get a little bit more of a feel for some of these problems. So this is on, like I said, this is out of your book, and let's see about working some of these out here. All right, so I'm going to go ahead and pause this for a second, and we will get right back to this. Okay, guys, so I figured out that I put this slide in the wrong place. So these are actually going to be from your review that is for tomorrow. So don't worry about doing these. The only thing you have for homework are these problems right here. Thanks. Have a great day.